Hey everybody, this is Mr. Longo, and in this video we're going to talk about domain and range. We're going to work with some graphs, and we're going to work with functions, just listing the domain based on some of the rules we know, and we'll see where it goes. For domain and range of a graph, domain you have to think x values, which is left to right. With range, you're working with bottom to top, your y values. Now, for the graphs, we're going to write in what is known as interval notation, and that means you pick the leftmost point, comma, the rightmost point for domain, and then, of course, bottom and top for range. Special note, if a number is included, you use a square bracket. If something is not included, you would use parentheses, okay? So, for domain of this first one, it is going left forever and ever, which would be negative infinity. We don't use a square bracket for infinities ever because you can't include infinity because infinity never stops. Comma. And it goes right forever and ever, so we have positive infinity for the far right. With range, it goes down forever and ever, giving us negative infinity, and it goes up forever and ever, giving us positive infinity. Now, both of those are like saying all real numbers, okay? If you're going from negative infinity to positive infinity, it's all real numbers. So another notation that you could have used is x is equal to all real numbers, and y is equal to all real numbers. But we are going to have to be able to adapt to the notation we are asked for at certain times. So for the graphs, we're going to practice interval notation. Okay? So for this blue one right here, we are going left forever and ever. We are going right forever and ever. So this is our negative infinity to positive infinity. But our range goes down forever and ever, but it never gets past 5 on the way up. So this is an example where it goes down. Remember, the left coordinate for range is how far it goes down. That's negative infinity. But the highest point is 5. Okay, it'll never get higher than 5, which means that's an absolute maximum for the graph. So we use the bracket because 5 is actually included. Okay, so those first two examples are kind of what these next couple are going to do. So for the next 3, if you would like, press pause and see if you can answer the next 3 without my assistance, and then click play when you're ready. Go ahead. Domain, the leftmost point for this one is -6. You can see it never gets less than -6, but it goes to the right forever and ever, so that's going to give us infinity. Our range, the lowest y value we have is 4. And then it's going to go up forever and ever, going into infinity. So if you have that, you are correct. For the purple one, this one is just going backwards, kind of opposite of what we just had. So it's going left forever and ever. So it is going to negative infinity, but it never gets bigger than x is equal to 7. And it goes down forever and ever, going up to nothing higher than 6. So that is your domain and range for the purple one. The red one has a left and a right, and a bottom and a top. This one will not have any infinities because we don't have any arrows. So the leftmost point is a -4. And the rightmost point is 5. And since it is connected by lines, all possible values in between are included, including things like 1.2765 and 4.999999. So just remember, when you're connected by a line, it includes everything in between. I mentioned that because the next one is a little different. For the range, the lowest y value we will have in this is a -5, and the biggest y value we will have is 2. So those 3 should have been fairly simple. But this next one is a little different because they're not connected by a line. So when they are not, all we have to do is list our x values for domain, which would be our -8, -4, 0, 4, and 7. The range, we would just list our y values. So I like to work bottom to top, -7, -3, 4, and 8. Now, it's okay if they have different values here because, look, we have the same y value twice here. This is a function because it does not have any x values that give you two different y values. So this is okay to happen like this, all right? So that's domain and range when you're looking at a graph. Now, when we are working with a function and we are actually trying to determine what the domain is, most of the time it is easier to think about these in terms of what can x not be. So when you're squaring a variable or multiplying a variable, no restrictions whatsoever should come to mind. You can square a negative, you can square a 0, you can square a positive. You can multiply a negative, 0, and positive by a number. So for this first example, this is x is equal to all real numbers. So I'm going to switch to just a regular notation for domain for these because it's much easier to do when you're working with functions. Now when you get to the second example, there's something you need to remember. You can take the square root of a positive number, you can take the square root of 0, but you cannot take the square root of a negative number. So whenever you're working with square roots or fourth roots, sixth roots, any even root, you have to remember the inside has to be greater than or equal to 0. So if you were solving this inequality, you would just get x is greater than or equal to a -3. And that's something that you want to remember for all even roots. The third example, you have something in a denominator. Now you should remember from back in the day that you can divide anything by anything except 0. We cannot divide by 0. We can divide by a positive number, we can divide by a negative number, we cannot divide by 0. So a little tip for these, when you have a denominator, you set your denominator not equal to 0. Add 3 to both sides, and x cannot equal 3 because if you plug 3 into this function, you would get 9 plus 5 is 14 over 0, which is impossible. That's why we have a domain of x cannot equal 3. Finally, the last example here. We have both. We have an even root and we have a radical. So why don't you pause the video for a second and see if you can figure out what your domain is. Now, if you said x has to be greater than or equal to a -2, but x is not allowed to equal 1, you are correct. Okay? And that's it for domain and range. For this one, just to remember, the reason why we have this is because the radical cannot be less or cannot be negative. That's why we set it greater than or equal to 0. And we set this guy not equal to 0 and just solve both and put it together. All right, that's it for this one. This is Longo and I'm out. See you, bye.